Welcome back to the lecture series in subculture technology. So, to start off with, so now doing a surface analysis, and one of the easiest and most thorough surface analysis what you can do is XPS. XPS stands for X-ray, photo, electron, spectroscopy. So, this is one form of a spectroscopy where what you do, the emerging beam. So, you try to understand in simple language, you shine a radiant energy on the substrate and it has its certain level only, you do not go very high on it. Okay. Now, what this does, this ejects out, say for example, let me draw it, that will make more sense. Say for example, you have a substrate like this, and this substrate has this different color of elements which are present, red, say blue, green, light green, pink, okay, like this. Just to distinguish, I am kind of making it slightly darker. So, this is how the surfaces mix up. Okay. Now, essentially speaking, you have 6 different colors or 6 different atoms or elements which are present on the substrate. Now, let us give them some different names. Okay. Say I say this blue stands for silicon, dark green stands for carbon, red stands for say nitrogen, light green, this say stands for, so the surface has lithium. I'm just for your understanding sake I'm telling you. And a lighter pink which may stands for say hydrogen, and this one stands for oxygen. Now you shine a emerging beam out here. Do not worry about it, what you are shining at this point. What this will do is, on the surface whatever is present, it will eject out the outermost electrons, and each one of those outermost electrons which are being ejected out, so I am representing them by the respective colors of that atom or of that element. Okay. And now, each one of these electrons which are ejected out from this surface are coming with a different kinetic energy. Okay. The energy of emitting an electron is different from different atoms, where the different atoms are of the different colors. Now, if you have a detector sitting here which could detect those speeds, then it will be giving you, say for example, in that case 1, 2, 3, 4, 5, 6, 6 different signatures. And if you have already done your 6 different energy signature, okay, and if you have already done your base calculations right, say for example, you already have a library. How you create the library? So you do the same experiment with under this situation. So for example, you have a so these are pure substrates what we are talking about, okay? And exactly do the same experiment. You shine each one of them with particular radiation. So each one of them will be emitting it with that unique velocity. So you have already the table at your disposal where you know the basic table is the library of E values or energy values for different elements, right? If you know that value, then what you can do is you can back calculate from this mixed substrate and you can figure out what all elements are present on that particular substrate, right? So this is how you analyze a substrate, that what all different elements which are presenting on a substrate, and this is one powerful tool which help chemist, biochemist, material scientist, everybody to understand the surface chemistry, especially people who does work on electrochemistry and all other fields, analysis of electrodes, because you have to, because anything, any phenomena which is a surface phenomena. So you have to realize what I meant by surface phenomena. So when we talk about a substrate, here is a substrate and cells are attaching on the substrate, we are talking about some form of surface interaction. So one needs to analyze this surface interaction very carefully. And for surface analysis, one of the most powerful tool, so what you see is a basically a not a bulk property of the material, but a surface interaction between cell and surface. It could be any surface, and the interactions are shown here in the red color. Okay. So now, unless otherwise you know the surface chemistry of any material, it is extremely tough for you to quantify that why this interaction is happening, who is bonding with what. Okay. To that level, the technique is so powerful. Within this particular, say I talk about the red here, say talk about nitrogen, the speed with which the different electrons from nitrogen are ejected, from whichsoever orbital it is coming, from most of the outer orbitals of course, You can even go down and figure that out. It is that powerful a technique. But remember, it is a surface phenomena. It is not going to tell you anything about the bulk material, and we are not concerned about the bulk. And when I talk about the bulk, I talk about, suppose this is the material I am talking about, I am not bothered about the whole bulk property of it. This is what I am hatching the lines. This is the whole bulk of that material. Okay, I am only bothered about just what is happening on the surface. The surface reaction. And of course, there is always a very interesting interface. So we are not talking about it. Okay. So any surface phenomena needs to be analyzed very analytically about the presence of different kind of elements which are there, because unless otherwise you know this, say for example, think of this, suppose your surface has higher carbon. So now, having said this, I will take you to the next flare into the game. Using this technique, you can even quantify. It's a little tricky. It's a little tricky to do so, but you can actually quantify the amount of carbon, nitrogen, and all other XYZ elements out there. And if you can quantify, so you can develop a ratio. Say for example, I say C is to N is to, say, silicon is to say lithium is, just put some numbers, say 5 is to 1 is to 2 is to 0.5 or 1, okay, whatever. So in that situation, you know that, okay, so this is the composition I am getting when I am coating the substrate with this specific material, right? So that way you not only have a qualitative estimate, you also have a quantitative estimate of individual elements present on the substrate or surface. So this is a powerful tool which generally not used by the biologist very frequently, but those who are intensely into cell culture, they may like to look at this technique. Apart from it, when we talked about the analysis, we talked about contact angle measurements. This contact angle measurements could be done with the instrument called goniometer. Okay. And of course, atomic force microscopy, you needed an AFM setup to do the surface analysis. So now if you summarize, you have a physical surface analysis in the form of AFM. You have a contact angle measurements which will tell you the interactive behavior of the material in the presence of water or aqueous system, and you have a surface analysis, both quantitative and qualitative. So once you analyze the surface, or you know the tools to analyze a surface, you know how much power you have now really to approach to a problem. So now I give you any material, irrespective of whether you know the nature or not. I may give you even a random stuff. I say, this is going to work. How you should scientifically proceed, the experimental science wise. You first of all do different dose dependency of dissolving. If, of course, the assumption here is if it is a water soluble. If it is a water insoluble, of course you can do. You just have to know how to, where you have to dissolve and, put it on the surface. If it does not dissolve in aqueous, it will dissolve in non-aqueous solvents. Okay. Then too you can make a thin films. Of course, that is not the application, is not towards cell culture. Application may be something else. But see, the point is, we are not bothered about where or you are going to apply, because you will be going places and doing different kind of scientific endeavor. What is important is that you should have an idea that what all tools are there in my armory which I can use to analyze surfaces. So definitely these three are some of the very potent tools. So you coat the surface, so you coat at different concentration. Suppose I take concentration 1, concentration 2, concentration 3, concentration 4. Okay. In our case, say polydyl lysine, we take 4 different concentration. Since this is aqueous or dissolved in water, it is easy for us to do it. Now I take AFM, so I have 4 different AFM images. Okay. Then on top of that, I do a goniometer analysis or contact angle analysis. So now I know that what is the difference, if at all. So my hypothesis is that whether with the increase in concentration, the hydrophilicity or hydrophobicity will change. The alternative hypothesis could be it will not change, right? You can test your hypothesis by simple experiment. You can say, if I deposit, say, this milligram per ml on the surface, this is what I am going to see. Or if I have y milligram per ml on the surface, this is what I will see. If I have z milligram per ml, this is what I am going to see. So with different dosage, you can see different kind of interactions which are happening. So that followed by this, you can go for what we call as surface chemical analysis, where you will be knowing that which all atoms are or elements of atom, so atoms of element are present on the surface. Okay. So that will give you an idea that, okay, these are the possible interactions which can happen with the cell. So now hereafter, what all we'll be discussing about the different kind of extracellular matrix, what we'll be using or what people use. I wish all of you should be, or at least I request all of you should be aware about the tools at your disposal, what all you can use to analyze surfaces. With few slight changes, we'll continue from here. Okay, thank you.